Hi, my name is Evan Bennett.
And my name is Nicole Verchio. Our presentation is on light and Heisenberg's uncertainty principle. Since quantum mechanics is difficult to experiment with, this will be an explanatory video of these two complex topics. Light can be described in terms of a stream of photons, massless packets of energy, each traveling with wave-like properties at the speed of light. A photon is the smallest quantity of energy which can be transported, and it was the realization that light traveled in discrete quantum that was the origin of quantum theory. Wave-particle duality concepts are used that all matter in the universe behaves as both a particle and a wave. We do not see visual objects as acting as a wave because they are too large. Although small objects such as photons behave as both a particle and a wave, which makes it difficult for us to understand their physical properties. So while photons propagate through space like a wave, it interacts at a point like a particle. This is known as wave-particle duality.
The interference pattern in the fracture. The motion of the wave through the molecular structure. I've been looking at it all wrong. I can't consider the electrons as particles. They move through the graphene as a wave. It's a wave! The moment to applaud would be now. Troglodytes.
Sheldon, where are you going? Aren't you going to clean this up?
Two physical characteristics of a wave are amplitude and wavelength. The amplitude of a wave is the height of a wave as measured from the higher point on the wave, the peak or crest, to the lowest point on the wave, the trough. Frequency refers to the number of waves that pass at a given point in a given time period and is often expressed in terms of hertz, or cycles per second. Longer wavelengths will have lower frequencies, and shorter wavelengths will have higher frequencies. The sun is a source of the full spectrum of ultraviolet radiation that is composed of photon particles. Electromagnetic radiation comes from the sun and is transmitted in waves or particles at different wavelengths and frequencies. This broad range of wavelengths is known as the electromagnetic spectrum. The spectrum is generally divided into 7 regions in order of decreasing wavelength and increasing energy and frequency. The common designations are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Gamma rays have the highest frequency and radio waves have the shortest frequency.
Heisenberg is a German theoretical physicist and one of the key pioneers of quantum mechanics. Heisenberg also made important contributions to the theories of hydrodynamics of turbulent flows, the atomic nucleus, ferromagnetism, cosmic rays, and subatomic particles. Next, we are going to talk about his uncertainty principle. Heisenberg's uncertainty principle states that the position and velocity of an object cannot be accurately measured or defined at the same time, even in theory. As stated earlier, in quantum mechanics, objects follow wave-particle duality. Particles are in a single place at a single time, except waves are more like disturbances, where they are similar to ripples in a lake. They have the probability of being in lots of places at the same time. The wave-particle duality concept makes it difficult for scientists to truly understand the quantum world. If a particle's position is known, then we do not know its direction and can therefore not determine the momentum. In order to acquire our best understanding of the quantum world, we must piece many pictures together. One of these pictures is a wave packet, which is a combination of different graphs of a particular quantum object and its occurrence to try to pinpoint its location and possible information about its momentum. As you can see in the image, the top graph is a depiction of all the separate graphs, and the bottom one is all of them compiled together to try to give us a pinpoint of the particle. Although there are downsides to using a wave packet, in order to try to understand the certainty of the position, you can increase the amount of waves that are used, except this will cause a lack of information about the momentum of the object. Vice versa, a bigger wave packet can give more information on the momentum, but less information on the location of the object. Thus, this is Heisenberg's uncertainty principle.
Thank you for watching and listening to our presentation on light and Heisenberg's uncertainty principle.